So hello everyone, this is Jay, your instructor for computer networks, and the topic of the discussion today is subnetting for class A. We know that the total IP addresses are divided into 5 classes, and right now we are only interested for class A. So in the class A, first 8 bits is for network ID and the remaining 24 bits are for host ID. So what information you get from the network ID and the host ID? The network ID will tell you how many networks are possible in the given class. So the length of the network ID is 8-bit. So in the class A, 2 raised to 8 individual networks are possible. And from the host ID, you will know that how many hosts are possible in one network. So the length of the host ID is 24-bit. So 2 raised to 24 hosts possible in one network. So from 2 raised to 8 individual networks, one class A network is given to you, which is 9.0.0.0. We know that in the class A network, the first 8 bits is for network and the last 24 bits are for host. Now I want to find the number of hosts possible in this given network. So to find the number of hosts in the given network, we have to see the length of the host bits, which is 24 in this case. So how many hosts will be possible? 2 raised to 24. Always remember, the value of the network bits will remain same throughout the network, but the value of the host bits will keep change as the host changes. So I want to find the first IP address of this given network. So to find the first IP address, the value of the network bit cannot change. So we will set all the host bits to 0 and you will get 9.0.0.0. And to find the last IP address of the same network, we will set all the host bits to 1 and you will get 9.255.255.255. Now, in any network, the first and the last address is never allocated to any device because the first address in the network represents the whole network. So 9.0.0.0, it is the IP address that will represent the whole network, and that is why it is known as network address. And the last address in the network is known as broadcast address. What is the meaning of broadcast address? Broadcast address means that any message sent to 9.255.255.255, all the devices in that network will receive the message. So it is the broadcast address. So any IP address apart from first and last will be allocated to the devices in the network. So what will be the IP address of the first device in the network? So first device will get 9.0.0.1. Then after that, the device will get 9.0.0.2, then 0.3, 0.4, 0.5 up to 0.255. If you increment 1 to 9.0.0.255, you will get 9.0.1.0. Then 1.1, 1.2, 1.3, 1.4 up to 1.255. Then 2.0, 2.1, 2.2, 2.255 and 3.0, 3.1, 3.2. And if you keep incrementing like this, the last usable address that you will get will be 9.255.255.254. So that is the last usable address of the given network. If you increment 1 to the last usable address of the given network, which is 9.255.255.254, you will get the broadcast address, which is 9.255.255.255. If you further increment 1 to the broadcast address of the given network, which is 9.255.255.255, you will get 10.0.0.0. Notice the value of the network field is changed. It means that represents the another network. Now let's see the value of the subnet mask. So to find the value of the subnet mask, we will set all the network bits to 1 and we will set all the host bits to 0. And you will get the subnet mask, which is 255.0.0.0. So what is the use of subnet mask? Using the subnet mask, router can find the network address from the IP address. So let's see how it works. So this is the subnet mask that we found of the class A, which is 255.0.0.0. Suppose router is receiving IP address of class A is 17.2.3.9. Let's rewrite this IP address in the binary and you will get something like this. Now the first address that you can see is the received address by router in the binary, and the second address is the subnet mask. So router will perform logical AND between these two numbers and it will get number something like this, which is 17.0.0.0. So from the received class A IP address, router has found the IP address of the network. You can see that it is the first IP address of the network, which is 17.0.0.0. So that is how router finds network address from any received IP address. Now we have discussed that in the case of class A, 2⁸ individual networks are possible, and in one network 2⁴ devices can be connected to the internet. But what if we want to create network smaller than that? So in that case, if we are creating network which has fewer number of devices as compared to one class A network, and if we are purchasing class A network, so remaining IP addresses will be totally wasted. So if we are creating smaller network as compared to the predefined class A network, in that case we have to divide the network into subnet. So subnetting is a process of dividing network into smaller parts. So this is the same example that we just saw. It is a class A network 9.0.0.0, and we know that in the class A 8 bits are for network and 24 bits are for host. Now I want to create subnet of this given network. So to create subnet, we will convert host bits into network bit. In this example, we are creating one host bits into network bit. So you can see that size of the host bits is changed from 24 to 23. It is reduced by 1. And the size of the network bit is changed from 8 to 9. It is incremented by 1. So what information you will get from the converted bit? From the converted bit, you will know that how many subnets are possible. So we have converted one host bit into network bit, so we will get 2⁴ means 2 subnet, which is subnet 0 and subnet 1. So let's find how many hosts are possible in the subnet 0. So to find number of hosts in particular subnet, we have to check the length of the host bits, which is 23. So in subnet 0, 2⁻23 hosts are possible. Now to find the first IP address of the subnet 0, we will set all the host bits to 0. So let's set all the host bits to 0 and you will get 9.0.0.0. And to find the last address of the subnet 0, we will set all the host bits to 1 and you will get 9.127.255.255. If you notice, the value of the converted bit is remained same throughout the subnet 0. So value of the converted bits is 0 in the subnet 0. Now in any subnet, the first and the last address is not allocated, because first address in the subnet represent the whole subnet. So 9.0.0.0, it is the address of the subnet 0, and 9.127.255.255, it is the broadcast address of subnet 0. So any message sent to 9.127.255.255, all the devices in subnet 0 will receive the message. So addresses apart from first and last address will be allocated to the devices in the subnet 0. So can you tell me what is the address of the first device in the subnet 0? So first device will get 9.0.0.1, then 0.0.2, then 0.3, 0.4, 0.5 up to 0.255. If you increment 1 to 9.0.0.255, you will get 9.0.1.0, then 1.2, 1.3, 1.4, 1.255, Then if you increment 1, you will get 2.0, and if you keep incrementing, the last usable address that you will get is 9.127.255.254. Are you getting it? So that is the last usable address of the subnet 0. Now I want to find the first address in the subnet 1. Before that, let's find how many hosts are possible in the subnet 1. So for that, we have to check the host bits, which are 23. So 2^23 hosts are possible in the subnet 1. Now, to find the first address in the subnet 1, you can follow two methods. In one method, you can add 1 to the last address of subnet 0. So what is the last address of subnet 0? It is 9.127.255.255. So if you increment 1 to the last address, you will get the first address in the subnet 1. That is one method. Second method you can do is that you can change the value of the converted bits from 0 to 1 and set all the host bits to 0. So the first IP address will be 9.128.0.0. And what will be the last IP address in the subnet 1? So to find the last IP address, we will set all the host bits to 1. So let's set all the host bits to 1 and you will get 9.255.255.255. The value of the converted bits is remained same throughout the subnet. So in the subnet 1, the value of the converted bits is 1. Now again, in any subnet, the first and the last address will not be allocated to any device. So the first address in the subnet 1 represent the address of the whole subnet 1, and the last address in the subnet 1 is the broadcast address. So any address apart from first and last will be allocated to the devices in the subnet 1. So what will be the IP address of the first device in subnet 1? It will be 9.128.0.1. Then 0.2, 0.3, 0.4 up to 0.255. If you increment 1 to that, you will get 1.0, 1.1, 1.2, and you will keep incrementing and you will get 9.255.255.255. Now let's find the value of the subnet mask. To find the value of the subnet mask, we will set all the network bits to 1 and host bits to 0, and you will get 255.128.0.0. So this is how subnetting is done in the class A. Now, this is the example that you need to solve by yourself. You have to divide the given network into 12 subnets and you have to find the starting and the ending address in each subnet. And the given network is 3.0.0.0. And this is it for today's session. If you have any doubt, you can ask me in the comment section. Thank you so much.